This is one of the real highlights of the leadership conference, is to celebrate innovation in the company. This is a transition that's also extra special for me this time in that, this has been Scott's thing and his recognition, the chairman's word of innovation. And this is really the first year that I have the honor to talk about the teams and introduce the people here. Which gives me thrill beyond mention. I mean, at the core of who we are is innovation, and it's not just innovation in product; it's innovation in process, in what we do, in how we do it, in our tools, and our whole mindset. I think we heard it best from George Weiss this morning from Gartner. Who is our Gartner lead analyst for people in the back, who basically said that we, Sun, play this vital role in the industry. If we weren't here, we would definitely be missed. And missed, I think, in a way much larger than our market share, right? That we are much bigger than life in this industry, given that, the people above us are so big, right? People like Dell, HP and IBM. And you don't, when you think innovation in computing systems, you don't think Dell. That's not, right? People will think us certainly ahead of that. So I view it as all opportunity for us. So in this year, we've also really moved things along. It's been a great group of folks, an emphasis on small teams, an emphasis on things. It's not just product innovation, but process and project. A big thing about community and how we go and relate and build communities, and we'll be honoring all of that. So sit back and enjoy this. And as I said, this is a celebration. There were 51 nominations, and we selected only 11 out of this. And you hear this all the time in these kinds of honorings. There are so many where they really are. I mean, just a fabulous amount of stuff that's going on, and I consider that all upside. So the way the flow is going to work is we have 11 of the teams, and you see them all represented in the back here. We're going to come, go through each team. The first team, I'll announce the team title. And introduce the people who are on the team, and then I'll say a few words about it. They'll all be coming up during this time and seeing Jonathan. So without, I think we have this right? Okay. So without further apologies, we'll start with the Constellation 48 team. So if I could please welcome up here Yu Chen, Jim Lagasa, and Hassan Siapolo. And okay. So this is an amazing example of extraordinary product innovation with a small group of folks. And you know what? It started by really listening to a customer. And this was going in, and you're going to hear more about TAC tomorrow, but it was essentially listening really hard about what their problems were and what we might be able to do to come and solve that, pulling all the technology that we had. A piece of that, and a really important piece, is packaging and design. How do you get sort of the space and energy efficiency to make that work? So the Constellation 48 is taking the Constellation family system blades, building I say it's a full bleed chassis, the unibody, I guess, which is essentially, there are no rack mounts, there are no ears, there's no separate rack. It's a co-design of a single system. What that lets you do is go from 10 to 12 blades in a side, and that in a shelf. And what that immediately lets you do is improve density by 20%. But it has all of these cascade effects of integrating first layer of networking and all that. It's just a fabulous thing, and there'll be a lot more to said about TAC in the end on that. But I think this is very much the shape of things to come. If you look at something like a Constellation 48, that's every bit as much power in a box as an E25K. And we're in it itself is a component in a bigger system. So thank you all. Wait, we're going to have photos. We're working this out in real time, of course, because we rehearsed all this stuff and
That's good, guys.
Here, somebody who, not me.
Don't
okay.
drop that.
Thank you. Thank you. Okay. The next team to be recognized is the team establishing the Glassfish open source community. And the members can come up and I'll read off their names. Jean-Francois Arcan, Ludovic Champenois, John Klingham, Jerome Doches, Arun Gupta, Mahesh Kannan, Kosuke Kawaguchi, Vincent Kramer, Anissa Lam, Jan Luhe, Alexei Musin Pushkin, Kedar Maswade, Scott Oakes, Eduardo Pellegri Lopart, and Sahu. Now there is a number one myth in open source is that you put an open source license on code and you throw it over the transom and the magical thing happens, these communities form around the code and you have to do less work because other people outside are starting to code for you and fix your bugs. That is so far from the truth. Building a great community is a huge amount of work. And what this team has done is really very much shown us a path of how do you really go about engaging and building great communities on the outside. And I'll start really, Glassfish is a great code base in its own right, and but I would say, and going back to some questions earlier, a couple of years ago, you would not put Glassfish on the number one, number two in the market, right? Or 3 or 4 maybe. And there was really a time when I was going, talk about hard choices, and saying, do we really want to do this anymore? And Jonathan's going, no, this is going to happen. We're just going to stay at it. We're going to go figure out how to make this work. It's terribly important to the industry and to an essential piece of our future. And through the greater Glassfish team, but also really these folks working tirelessly to be totally active and engaged with those external communities, spending a lot of time on doing that. And it's really an active area. Glassfish is growing like crazy. I guess there are 2,000 members or so in the community as we count it now. And here's an interesting factlet for you here. During FY08, Glassfish acquired over 50 new paying customers, many who had never visited a Sun sales representative, all through the hard efforts and activities as well. Okay. Take that? I think we have to.
Specialized in density.
Thank you. The next team is highly efficient, scalable, and flexible data center design architecture. And the team members, can come up, please. Brian Day, Serena DeVito, Ramesh KV, Dean Nelson, Mike Ryan, Brett Rucker, and Petra Velocity. And a small team that has totally kick butt. Let me just start this by saying in 2 weeks, I'm going down with Dean and Sabode. We're going down to FedEx, a special request to go down that the FedEx is in the middle of a $250 million data center build. They, on a trip out here, at kind of the end of the trip, they went and visited one of the examples of the facilities that these guys have helped engineer and create inside of Sun in Santa Clara. For all of you who haven't visited that, it is a must-see. They were so impressed about what these folks have done to really do efficient, modern, highly flexible, fast data center design and really bring that out in the forefront and experiment with it. In fact, what you see when you go down just to look at the version of this in Santa Clara, we have I think it was just the Santa Clara site alone, we got $1.2 million in energy rebates, another $250,000 innovation award from Silicon Valley Power, which is the local utility, just for saving them from having to build essentially new generation capacity because of what we've done. We're helping consolidate, lower costs in the company, improve efficiency. This is just a beautiful demonstration. And so customers like FedEx who come through, and there have been more than 2,000 people have toured the data center there, including Senator Barbara Boxer from California. So these people also, in addition to doing their job, also act as tour guides now. But it's that impression of we so get it that has invited us down to basically be the consulting team with FedEx to really help them navigate what they're going to do with their $250 million. And we have lots of ideas on how to spend that. I would also want to point out that this is the first award for workplace resources. So. And the next team is the Open Solaris kernel-based CIF server. And the people on this team are Alan Wright. Please come up. Do I have the right team here? Yep, okay. Alan Wright, Jose Borrego, Rich Brown, Casper Dick, Doug McCallum, Joyce McIntosh, Reza Sabdar, Afshin Salek, Mark Schellenbaum, James Wallach, and Nico Williams. So we heard all the excitement. People missed the last session by John Fowler, who was waxing poetically about open storage and how we're going to revolutionize the world here. There's something really, really important in storage land that if you want to be a big player, you've got to interoperate with Microsoft. And CIFS is to Microsoft what NFS is to the rest of the world. So it's the network way of talking to systems. And to be credible, you have to do a really good job with that. And so this team actually did one of the largest putbacks in the history of Solaris. 800 files, 370,000 lines of code. Bug-free code, perfect code. Actually, along the way in doing this is they went and solved some problems, some hard problems that hadn't been solved before in this kind of integration, and yet more sort of evidence of the kind of innovation we do, and put things in getting authentication systems and identity management to work right across domains in Microsoft and the rest of the world. They also solved a really thorny problem about case insensitive versus case sensitive path names and all this. This is going to be one of the hallmark attractors into Open Solaris as an open storage platform. So congratulations, folks. Go ahead. We don't want to lose anybody here. The next team, Project Black Box. So let me, Joel Cargill, Maurice Cloutier, Lee Fulmer, Tony Fredrickson, Elizabeth Frum, Jeff Galloway, Timothy Jolly, Carl Meske, Ken Nagata, Chuck Perry, Russ Rinfret, and Bill Schilmolen. The single most, I was about to start, what a brain dead idea. Single most iconic product, it really is, just the value alone of representing innovation is there. I think one of the hardest things that we have to do, and I'm sure you experience this every day, say, well, what do you do? Cocktail conversation, it's on Microsystems. Oh yeah, computing, huh? What do you make? Well, we don't make a consumer thing that people go, oh yeah, I see that, or whatever. You said, well, we do computing infrastructure and software and have all these developers out there and databases, and people just look at you sort of, very puzzled. But yeah, black box is something you can point to, right? It's at least for a big swath of our business is a physical manifestation of something, and it's just really interesting and attractive to folks. It's been hugely visible. It actually had an invitation to exhibit at the real inner court of CeBIT, which is a great honor. We had 2 units on the world tour. 15,000 customers came to see it and walk through the systems. It's, part of the idea here is that this is kind of the way that things should be done, that, you don't touch it, it's equipment, moves in. Stanford Linear Accelerator SLAC was one of the first customers. They've got a full payload of 252 X2200 servers. And their customer quote is, you know what, this is really boring. It just works, which is just what you want. One of my favorites was a feature article in Scientific American, which is always great for the geeks. But for me, a real accomplishment was this team made InfoWorld's 2007 list of 12 crackpot tech ideas that might just work. So, thank you. Okay. Next team, Project Sunspot. I had nothing to do with the selection of the folks here, by the way. So just to be clear here, obviously very proud of these folks. Let's bring up the team. Bob Alkire, Eric Arsenault, otherwise known as Eric Arsenio, Ron Goldman, Vipul Gupta, Leo Hirsch, Roger Mike, Pete St. Pierre, Arshan Prasoi, David Simmons, Randy Smith, and Derek White. So, just so people know, sunspots are these very cool little wireless battery-powered sensors that have. The second most. Oh, we have one. And if I shake it, does it do something? Or yeah? What does it do? Like we're
stuff upside down, I think.
Oh yeah. Does that do anything? Okay. It is, this is a full sensor pack, microprocessor interface, huge hack value, radio on here. One of the very cool things about this is that the software that it runs is actually the team, the Java Squawk virtual machine, it's pure Java down on the metal. So this thing sort of boots up Java, all the device drivers, interrupt panel, everything is done in Java. What it's really done is opened this up to this arcane world of embedded programming, which is really hard to hack on for lots of folks. It's opened up to lots of people, made it huge into 250 universities, I think, so far. Go to YouTube or Flickr and just go do a search for sunspots or spots, AUGHT something, right, is the tag, and you'll just see everything. model rocketry, balloons, art projects. It's huge. Actually, for people here who heard about the Campus Ambassador program, each Campus Ambassador had some sunspots to hand out on campuses, really. And just one last thing I'll have you think about here is we saw Second Life and that demonstration. One thing that, a lot of things you could observe about that, other than people not wearing clothes, is that there's actually very little connection between virtual worlds today and physical worlds. And what one of the next phases is going to be that interconnectedness, that the virtual world will actually reflect some parts of the physical world, and that's going to be done through sensing and through affecting and displays on the other side. And these kinds of ideas are going to play big roles in it. And we're not only getting students excited around the world, but enabling a whole tool chain. So thank you all. Ooh, one second, Roger. Okay. Thank you. Do you want it back, Roger? Thank you. The next team is Rust, Random Ultraspark Test. Yeah, that's kind of test. David Bogdanov, Kevin Clack, Alan Johnson, Andy McPhee, Ann Powell, and Joel Storm. This is one of those things that for most people, like, what? What is this? With all of that we see with Intel taking market share and microprocessor world and all those things, there are areas that are real big blind spots for them. And one of them is actually ever really getting many processors to work well together. They have verification issues that they seem to trip over all the time. And we've built over the years here a real deep skill set in how do you verify things that are increasingly complex, multi-core systems and the like. And one of the great artifacts there is the Rust suite. And you want to think about it, it's its own runtime system. You can boot it up on platforms. We've done, I guess, everything from UltraSpark 3i all the way through to Victoria Falls, Rock, and Niagara series. This thing takes debug time down from weeks to days and days to hours. It's just a hugely productive tool. And I wanted to also point out, we innovate in lots of ways, and innovating around tool sets and taking time out of time to market is as big a return as a new faster thing, because particularly in the processor business, every month has some performance value to it in the marketplace, and just an outstanding job. Thank you all. The next group is service tags. Simple is best, indeed. Joey Canlis, John Lilly, Martin Mayhead, Pat Ryan, Peter Scoe, Jeff Shoup, Todd Wickers, David Wood, Jamie Wood, and Mike Wookie. Okay. You saw a lot of this highlighted in Rich Green's talk. One of those kind of central things in that, that gulf between the gap, if you will, between enormous adoption at one end and people downloading stuff and trying and monetization at the other, is this ability really to connect and to understand and to be able to project service and knowledge and all kinds of things, both to understand what's going on out of the customer as well as being able to take care of them. And so I would say, and where's Wookie? Look at Mike and Dave Douglas out here. It's been well over a decade that we've been working on trying to do various service, connected service architectures. We know it must be, right, that kind of continuous connection to deliver service over the network is critical. It's a critical piece of how we look at the not free but open source software. Anyway, so and the other part of this that you should know about service tags. So service tags can go, any IP connected device, go populate both hardware features as well, and really importantly is software in there in real time. I guess we have 140 some products. This is maybe has changed, improved here, but more than 600,000 items been registered to date, and almost 1 million now. Goes by thousands a day, that's it. And if anyone here hasn't seen Jonathan's pink dot map, you should probably go out and leave. You definitely have not been paying attention, but that's powered by service tags. That's essentially what we go harvest, and this is just this is the magic, man. That's how we convert all that stuff. So thank you. Yeah. Thank you. I'd also just to comment on this too. This is one of those things of, it's kind of like Glassfish. You just have to stay at it. It's important. You got to keep doing it. And however many times it takes us, we're going to get that one right. And it looks like we did. The next team, Solaris 8 and 9 containers, aka Etude. And the team members here are Penny Cotton, Claudia DeBlau, Susan Hamwe, Jerry Jelinek, Steve Lawrence, Jerry Ann Meyer, Ed Polotowitz. Did I get that right? Yeah. All right, excellent. Dan Price and Joost Plonk. Popular crowd.
They really love you.
Yeah, they really love you. One of the chronic problems we've had has been the synchronization of the mandatory synchronization of operating system releases with new systems, new hardware in particular. And so it's been this thing forced upon our customer that if you want to take advantage of the newest system innovation, say Niagara, well, you get to go to Solaris 10. All right, so we actually put things in our own way of people getting to be able to use those systems and sort of have that synchrony. And for a long time, we tried to figure out different ways of breaking that. It actually was the original reason for getting Hypervision into the Spark microprocessor. The A2 team actually did just a wonderful thing, which was figured out ways of taking Solaris 8 and 9 customers onto new systems by using containers, providing compatibility there, and not forcing the complete retest and rebuild of the application stacks and doing that. So it really is, I think it's definitely, this is fashion forward stuff here too. When you look at the uses of virtualization and what it's really going to mean and bring you back into the management theme, fundamentally is about decoupling decisions around infrastructure from decisions around applications and deployment. And this is just a brilliant example of that. We've been able to migrate customers off of even hardware which is end of service life onto new and shiny things, which is great. And then you get things like you can take Solaris 10 features like dtrace and use them on older applications and things like ZFS as well. So really well done. Thank you. The next team is Sun Systemic Security. Yeah. All right, come on, good. Rafat Alvi, Mark Blanket, Glenn Brunette, and Joel Weiss. There are lots of aspects of this effort that I really like, and we need to emulate. Security in particular is one of these things that adding features into products don't make things secure. Right? Security is one of those. It's systemic, right? The systems can be unsecure very easily by having a piece of them which is vulnerable or not having done the correct assembly of the parts. And we very often leave the last assembly step as an exercise for our customers. In fact, most of the industry does, right? Where people still seem to be happy to take the piece parts and try to fit it together. But in security itself, you really have to get it right. And what this team did was go figure out how to not only construct these trustworthy architectures out of the components that we have, but really figure out how to do this and get that translated into customers' hands and through the whole process of architectural best practices, really develop us as a leader now in industry and in government. And I'd also say that this whole architecture and the approach itself has been adopted really across Sun in a variety of Sun solutions, training and marketing campaigns. This ability to go create systems out of components that we have around. This is a continuing theme. And at the end of the day, when we say it's Sun Microsystems, this is our unfair advantage that we get to do this. So congratulations. And our final team being honored here is Victoria Falls, the world's first multi-socketed chip multi-threaded processor. So the team members here are Carney Chung, Scott Cook, Dennis Decker, Mary Jo Doherty, Eric Howe, Stefan Hurod, Sumti Jayarath, Tom Karabinas, Curtis McAllister, Steve Phillips, Cheryl Preston, Ramaswamy Siva Ramakrishnan, David Smentek, Ted Stubing, Jeffrey Su, and Ali Bodhisattva. So I know everyone is aware of the game changing that we've done with Niagara and Niagara 2 in the industry as a piece of our product portfolio. It's also one of those exponentials on the positive exponentials that we're all looking for in our portfolio. That is fabulous. As you know, Niagara 1 and Niagara 2 are single socket chips, 8 cores, 32 threads, and 64 threads. Being able to go to even larger connections of chips. Victoria Falls actually enables you to put 4 what are essentially Niagara 2 derivatives into a system. If you've been out here to the product fair, you may have seen Batoka, which is coming out. When is Batoka coming out? Sometime soon, this fall. But it's a 4-socket system that was in the X4600 chassis. Brilliant sort of reuse of that. 256 threads in this 4U thing. Well, of course, Maramba is already out. But the thing that is really amazing about this team, and if you don't know, to build microprocessors are like hundreds of people committed for years. These are the biggest engineering projects certainly in IT, the technology industry by far. This team actually went and did this design as a derived design from Niagara 2. They, just went in, figured out how they could reuse the maximum number of pieces in here, and like the execution that's been happening throughout the sort of Niagara-related family of projects, just really excellent execution. And this is again one of those examples of where execution and process and going about these problems the right way. This is real time to market performance kind of things again, right? You get it out earlier, that's worth just as much as a performance boost sometime later. I would say that they actually, I guess Victoria Falls came out just 5 months after Niagara 2 or something like that, which is stunning. And they did this while we were also at the same time moving them from Sunnyvale to Santa Clara. So on all factors, well done. Thank you. Actually, do we want to try to, can we all consolidate in here a bit? Thank you. And this is a bunch of threads here.
Just can't see the gentleman in the back.
Who in the back?
So is this on?
Yeah.
Yes. So I want to just augment what Greg said. And I was really struck by what George said this morning as well, and I, of course, totally agree with it. We matter to the industry a great deal. And what matters is not only what we invent, it's how we invent it. And to the discussion we had this morning with Martin around how do we win against far, far bigger companies that potentially have far, far bigger R&D budgets and far more mass and far more momentum, we innovate. And not just in what we build and not just in how we build it, but increasingly you're going to see how we go to market. And when you look at the collection of folks we just brought up, you see, to me, everything that's great about Sun. Everything we just talked about is great for our business. It differentiates us in the marketplace. We were just talking about Glassfish. How many downloads did you have? 4 million or so over the last 12 months? How many? 5 million. 5 million. So to me, that's 5 million sales calls.
I was wrong. You were right.
And why is it 5 million sales calls? Because of service tags. And what happens when we know where those folks are? Easy. We can sell them more complete, more innovative, more extraordinary systems. And so our business model, to me, is evident by what you all have done. I just want to say, on behalf of the leadership of the company, you made a huge difference last year. You're going to make an even bigger difference in the next fiscal year ahead of us. So again, thank you very much. And so with that, I think I'm going to invite you to join me for a glass of wine.
Or two.
Or two. Thank you again.